I'm Boris. I'm going to talk about the Objective-C runtime. And first, a short outline. I'm going to present the basics of the runtime. Then I will show what we can do with it. And finally, some more advanced and interesting uses. So we start with a brief history of Objective-C. It was designed in 1983 by Brad Cox and Tom Love at Stepstone. In 1999, we got Next Step 1.0. In 2001, we got macOS 10, 10.0. And since 2007, we've got the modern runtime with Objective-C 2.0. And that's what we're going to talk about. Just a bird's eye view of where we are. We're right between the foundation framework and Objective-C, which means the APIs we're going to see are all C-based. And there's one header file, which is the most important one. That's the runtime.h header. Nearly all functions which deal with the runtime are defined in there. So first, how are things represented in the runtime? The most basic block is the object, which is actually just a simple C struct with a pointer to its class, the ESA pointer. And that is used to determine which methods and which instance variables an object actually has. So there's another struct for the class. It also starts with the other pointer. So it's basically a thing called the meta class. It's needed because we need a definition which class methods are there in a class. What you notice here is the if-defs for the with the Objective-C 2 define. This means that since the modern runtime, we actually shouldn't use any of the members of the struct directly. It's opaque to us. So this is just to get an idea how it's represented internally, but nothing you should use in actual code. So class has a pointer to its superclass. It has a name, and it has some information, and then it has the most important stuff. It's a list of instance variables. It's a list of methods the class implements. It's a list of protocols the class implements. And finally, there's the cache. The cache is used to map from a selector directly to the code. It's just to speed up calling methods after you called them the first time. So what's a message? When we've got a message that we all know, like the do a thing on self with a thing object, this gets actually translated by the compiler to a call to Objective-C message send with two parameters that are always there. That's self, and that's the selector of our method. And finally, our parameters. In this case, it's just a thing. One thing to keep in mind, if you're trying to call Objective-C message send directly, there are actually three variants of it, depending on the return value of your method. There's Objective-C message send for most of the stuff. Then there's Objective-C message send strread for structs. And there's also Objective-C message send fpread for floating point. So it's actually more complicated than just one function for it. We have another struct for the methods. It consists of the selector, which is the method name, basically. It contains a char array method types. There's an internal format for representing types. It's called the type encoding. You're probably familiar with the add encode statement in Objective-C. That's when you're using this, it generates such a type encoded char and that's also what you get when you use the method types attribute of the Objective-C method struct. And finally, there's a thing called the imp. That's the method implementation. It's, as you see on the next slide, it's just a function pointer. The selector is, it used to be in the old runtime just a simple C string. Internally it still is, but it's another thing that's opaque these days. So you should never use the selector directly, but always use the NS string from selector or NS selector from string. I think recent versions of the compiler actually don't allow anymore casting directly to a C string. And then we've got the imp. You see it's just a function pointer. Every implementation has at least 2 arguments. That's self, the object you're calling the method on, and it's the underscores command. It's the selector you're calling. That's something you're also probably familiar with when you're having an Objective-C method. You can always use the underscore CMD to get to the selector that's called. And then, of course, you have the arguments depending on the method you have. A final thing about the runtime is the message forwarding. You're probably familiar with response to selector, which tells you if a certain object can respond to a selector. And if it doesn't, the runtime uses the forward invocation method and this is a way for you to get in there and say, I'll just forward this method, this message to another object. So you can override the forward invocation in your own classes. What this takes as an argument is an NS invocation. That's just an object which collects all the information you need to call a method. So it has the target object, it has the selector, it has the arguments, and after calling it, it will contain the return value. Another thing you need when you're doing the forward invocation is the message signature for selector. That's a way for you to say what the actual message signature is. So what's the return value of your method, what type is it? So what we can do with it, there's introspection of objects and methods at runtime. There's the possibility to dynamically add functionality to classes. And there's also the possibility to dynamically add instance variables. Introspection of objects and methods. Some ideas what we can achieve with that. It can be used for debugging, finding out which class actually implements a method, for example, at runtime. There's another idea to have generic support for NS coding. It's kind of a pain in the ass usually to manually implement it, and you can use the introspection of objects to just iterate over the IVARs that are there and to encode them. An example of this is the mantle framework created by the folks at GitHub. And it's generally a framework for model objects. And one use case, or rather one part of it, is this generic support for NS coding. So what does it look like when we're doing introspection? We will, for this example, we'll just take the NS object class and print a list of the methods that are available on it with name and return type. As you can see, there are 3 methods, or rather functions, we're using. There's a class copy method list, which gives us the list of methods the class implements. And it is 1 argument and 1 out parameter. It's the class, obviously, and you get back the count of methods. And there is an array of methods that's returned. You can iterate over this and then get the selector by using method getName. And you can get the return type with method getReturnType. So as you can see, it's pretty obvious, the API. The only thing that's a bit annoying is that it's a C-based API. So if we would run this code, we would just get a list of all the methods and its object implements. Dynamically adding functionality, some ideas what we can achieve with that. Also debugging, for example, you could just hook into an existing method of UIKit or something like that and print out the parameters that are passed to the method and see when it's called. It's something the Cocoa framework itself uses for key value observation. When you do KVO on an object, there's actually a class generated at runtime which makes sure that the observers get messages about changes for values. And another thing you can do with that is subclassing a class which isn't available on every OS release you support by just generating the subclass at runtime when the superclass is available. One technique that's often used when you're adding functionality at runtime is called method swizzling. This is used when you have a method that almost does what you want, but not quite, so we can patch it. This basically uses the method exchange implementations function. This can simply switch the implementation of two methods. So you are writing your own method, and you're just switching the implementations of both, and you could then call the old method from your new method. The code is a bit longer than just doing method exchange implementations, because it might be the case that the method you're trying to swizzle is not implemented in the current class, but in the superclass. And what you need to do then is, that's the if statement. You add the method to the current class, and then you're replacing it. And in the case that the method is implemented on in the current class, you just can exchange the implementations. One thing to keep in mind when you're doing method swizzling is it always looks a bit funny because, for example, we are overwriting layout subviews here of a UI table view in our own custom category. And we're doing some implementation. And to call the original implementation, we have to use as the name of our method, because at runtime they're swizzled. So my layout subviews will actually have the code of layout subviews and vice versa. So it always looks, when you look at it, it looks like this is going to be an endless loop, but it isn't. Another thing to keep in mind when doing method swizzling, don't do it often. Only do it when you really need it. That's some funny thing from the UIViewController.h when you decompile it, or rather class dump it. Some Apple engineer put this in here to make you aware that it might not be such a good idea, because usually you're relying on the implementation of the internal implementation of a method, and yeah, that can always change. So be aware of that. I'm showing a little code sample here to mangle with the result of a method. There's the class getInstance method. We saw that earlier. What we're going to do here is we take the NSDateFormatter class, and we want to change the value we get back when we are doing the localized string from date. What the class internally uses, we are trying to find out what it uses internally. So we're just guessing from the documentation that the string for object value, that looks like something it uses. And we're using adding code at runtime to check if that's actually true. What we're doing, we're first getting the original implementation of the method with method getImplementation and storing it in the original imp, just to show how to add a method, we're storing that implementation as a new selector thingy on the NSDate formatter. And then is another nifty thing we can do is implementation with block that allows us to use a block as the code for some method. What's interesting there is, or something you need to keep in mind, as you see, the block only has 2 parameters. It's missing the second parameter an implementation has, the selector. It's just something you have to know. And the implementation with block is quite straightforward. We're calling the original imp with the parameter we got, and then we're just appending some string to it. You can, of course, do what you want here. It's also a good way to debug stuff or to find out how methods work internally. You can lock arguments, or you can do whatever you want, of course, here. Then you, when you've got an imp, you can just use set implementation to switch it. And when we would run this code, we would just get a date with the appended changed string. Final thing that's probably the most commonly used one is dynamically adding instance variables. If you are creating a category on a class you didn't write, you might come to the point where you say, well, I need to store some additional properties here. And that's where the associated references come in. They allow you to just associate object values with objects. And it's a pretty straightforward API. There is, of course, a set and a get of the values. The only thing that might stand out is the Objective-C association policy. That's basically the storage class of the value you're storing. So it can be retained, it can be assigned, it can be copied, both in the atomic and non-atomic variants. So finally, some more interesting or more advanced uses of the runtime API. One thing is called higher order messaging. And we will conclude with a short introduction of a library, which is pretty nifty. It's called libx Objective-C. First, the higher order messaging. It's using a message as an argument to another message. That's the idea. What is it good for? One thing is the collect message. What this allows us to do is just in one line of code, we can call a method on all the objects in an array. So if we have got an array of strings and we're calling collect with a string by appending string, we can just append a string to every string in the array. How could we implement such a thing? We need 2 things. The first one is the so-called trampoline. We're calling it HOM for higher order method in this case. It's an object with 2 properties, the target object and a selector. You can see the constructor at the bottom. And we're using the message forwarding stuff I talked about earlier to actually achieve our goal. And we're doing a forward invocation. So this is, as I said earlier, is called when a method doesn't implement some selector. This is called. And we're just going to perform the selector we set on the object. And we are setting the result as the return value of the invocation. And the other thing we need to do is to ensure we've got the right method signature for our selector. As we saw, the target will be an array. So we're just using the first object in the array and getting the message signature from there. Of course, this code, if you're really deploying it, you should add some checks if there's actually an object in the array. Second part of the implementation is a category on an array. We're adding the collect method, of course, which just creates our trampoline with the collect method with an argument, which is an NS invocation. And that's pretty straightforward. We're just creating a new array, iterating over the array itself, and calling the invocation with every object in the array. As you can see, you can just invoke the invocation with a target. The invocation itself has stored the parameters you need, and then you have a method to get back the return value, and you just add it to the array. And with these two small snippets of code, you can implement this collect method. Final thing I want to mention is libx Objective-C. It's another thing created by the folks at GitHub, and it extends the runtime with quite some useful things. And even if you're not going to use any of the other stuff from the runtime.h, I think you should check this out, because there are a lot of interesting things you can do with it. One is called ext annotation, for example, that allows you to add annotations to your code. These are just strings you can query at runtime, and it's using associative references to achieve that. There's ext dispatch object. That's something like our collect method we implemented earlier. They did it for us. We can use that. Another thing is the ext multi method that allows us to have multiple method implementations, and the right one is chosen at runtime. Another thing is ext nil. That's a replacement for NSNull, which acts more like the regular nil by accepting any message sent to it. So you can put nil values into a collection without worrying about it at every point. And finally, another thing is ext save category that allows us to safely add a category to a class, which means it will check if the methods in the category are already implemented on the class, and when they aren't added. And there are many more. Like I said, I encourage you to check this library out. So, thank you for listening. I have some links. The most important one is the second one. You can get the slides and the sample code there, and also a long list of links. And I'd appreciate if you've got feedback on the talk, just send me a tweet or an app.net post. And what's also interesting, you can look at the source code for the Objective-C runtime, at least on Mac OS X. It's open source. And another thing that's interesting is the blog of Mike Ash. He posts about every week on Objective-C internal stuff, and there's a lot of useful things you could find there. Do we have time for questions? Okay. Any questions?
So just to confirm, so the Objective-C runtime API is all public API, what you showed? So as long as I'm swizzling only with public methods, this is total in accordance with the developer rules?
Yes, it's all public API.
Okay.
Just the thing is keep in mind the method swizzling, use it carefully.
But as long as it's public API, it should be fine.
Yeah, you are fine, but if you're, the problem is when you're doing method swizzling, you're usually relying on the internal implementation of a method, and that can always change. Other questions?
Yeah, just another question. How far can we go to re-engineer the Apple libraries using the runtime? Is it just possible, just a start, or is it not possible at all?
Well, we can use the method swizzling technique to basically poke around and see internally which methods are called in which order and which arguments they have. And when you're using the class dump stuff. You can see which private methods are there, and you can also attach to them. It's actually very useful for debugging. Any more questions?
Are you using method swizzling in a lot of products you have out there?
Excuse me, I didn't get the question fully.
Are you using method swizzling in products you actually are, like, that are out there a lot? Or
Not a lot. Like I said, it's something you have to be careful with, but in some cases you need it. It's gotten better with, since iOS 5, we can style UIKit more easily with actual public API, but before that it was very common to use method swizzling. And I use it a lot, but these days only very, very rarely. Okay, thank you.